Good morning Year 8 and welcome to today's maths lesson. Let's start off with a quick starter, shall we? Can you find for me 1/32 of 32, 3/4 plus 7/8? Can you increase 100 by 100%? And can you find the highest common factor of 6 and 8? Pause the video and have a go at these questions in your light blue books for me now. Okay, let's go through the answers. To find 1/32 of something, I need to divide my number by 32. 32 divided by 32 gives me what, James Gooden? 1. Brilliant. So I was looking for 1 for the first one. For the second one, I've got two fractions. I need to make the denominators the same before I add them. I'm going to make both denominators 8. Vicky, what's 3/4 as in something over 8? 6 over 8, great. We've multiplied top and bottom by 2 to give us 6 over 8. We're going to add those together now. 7 plus 6 gives me 13 over 8. I'm going to leave that as an improper fraction. However, you could have also written 1 and 5/8. That would also be correct. Next, I've been asked to increase 100 by 100%. So to start us off, Lily May, what's 100% of 100? What's all of 100? 100% of 100 is just 100. So if I want to increase 100 by 100%, I need to take my original 100, add on another 100%, which gives me 200. Well done if you got that right. Okay, let's talk highest common factor. What does factor mean? Well, a factor is a number that goes into, a whole number that will go into another number. For example, the factors of 6 would be 1 times 6, so 1 and 6 are factors, or 2 times 3. 2 and 3 are both factors. For 8, we're looking for 1 and 8. 1 and 8 are both factors, and 2 times 4. The highest common factor is the highest number that's a factor of both, which in this case is going to be 2. Okay, let's head into today's lesson. So yesterday we were looking at inequalities with only one side, one number on them and one inequality sign. Today we're going to move on to looking at questions where we've got two inequality signs, and we're going to revisit showing those on a diagram. So a quick recap. We had this symbol here, which we said meant the same as. We had an equal sign with a line through it, which meant not the same as. We had a greater than symbol, like 8 is greater than 6. We had a greater than or equal to symbol, so 8 is greater than or equal to 6. We could also have 8 is greater than or equal to 8. This was our less than symbol, so we said 6 was less than 8. And we said we had less than or equal to, so 8 is less than or equal to 8. We have to include that number. In your light blue books, please pause the video for 5 minutes and have a go at these questions at the bottom. Can you tell me, are these inequalities true or false? And these are the answers. All the ones I've ticked are true, all the ones I've left are false. Okay, another quick recap. We were displaying inequalities on a number line, and we said if we had a filled in circle, that meant the number itself was included, and if it was an empty circle, it meant the number itself was excluded. So for my first example, I've got n is less than 3. Now it's not less than or equal to, so we cannot include the number 3. However, we need to include all the numbers that are less than 3. So I need to now draw an arrow going in this direction. For the second one, I've got n is greater than or equal to negative 2.5. Now this equal to sign means that I need to put a dot at 2.5, and this time it needs to be filled in because we're including that number. We're looking for all the numbers that are greater than or equal to negative 2.5, so our arrow this time is going to be headed in this direction. Because all the numbers like negative 2, negative 1, 0, they're all greater than or equal to negative 2.5. Okay, Year 8, in your light blue books, Is it A or is it B? Is it C or is it D? Which inequality has been represented by this number line? Pause the video, have a little think. Okay, let's work it out. We've got a filled in circle, so we know that number is included, so 1 is included. We've got an arrow going less than, so we want all the numbers that are less than 1, but including 1. So the answer I was looking for is B. And the next one, pause the video, and in your light blue books, is it A, is it B, is it C, or is it D? Okay, this time I've got an empty circle, so we're not including that number. But again, we want all the numbers that are less than 2, not including 2. So the answer I was looking for is A. So there's another type of inequality I want us to discuss, and that's a double-ended inequality. So I've been told I'm thinking of a number that is greater than -5, but less than or equal to 5. What could it be? So we need a number that's greater than -5. That's constraint number 1. And we need it to be less than or equal to 5. Those are our two constraints on this number. So looking at the first one, we need x to be greater than -5. So we need x to be greater than but not equal to -5. That's my first constraint. My second constraint on my number is that x has got to be less than or in fact equal to 5. So we've now got two different inequalities. We've got x is greater than but not equal to -5, and x is less than or equal to 5. We're going to put those together, and to do this we're going to put x in the middle. We know that x has got to be less than or equal to 5, so if I put a less than or equal to sign here, less than or equal to 5. We also know that x is greater than -5, so if I put -5 here and put in a greater sign, we've put those inequalities together. Here we've got an equality that shows both that x is greater than -5 but not equal to, and less than or equal to 5. So in your dark blue books, can you write the title Listing Integer Values for me? And put a little side heading, double inequalities for me. So listing integer values with double inequalities. And when you've done that, pens down, eyes on me, I'm going to go through some examples and then you're going to do some examples. Okay, so I've got x is greater than 2 but less than 5. I haven't got that equal sign in there, so I know I cannot include the number 2. However, I can include the number 3, as that's greater than 2 and less than 5. And I can include the number 4. So that's my first answer. How about the second one? Logan, what's different about this one? What's changed is we've now got this less than or equal to sign. So this time I can include 2, I can have 3, I can have 4, I still can't have 5 because I haven't got an equal to sign on that side. And for the last example, I've got 5, x is less than 5 but not equal to it. So I could have 4, I could have 3, 2, 1, 0, -1, all the way down. It's got to be greater than or equal to -2, so I can include -2. Over to your year 8, in your dark blue books, can you pause the video for 5 minutes and list the integer values for each of these inequalities in your dark blue books now, please. Okay, let's look at some answers. This time I've said 2x is greater than 2 but not including 2, so I can have 3. I can have 4, and I've said x is less than or equal to 5, so this time I can include the number 5. I'm looking for 3, 4 and 5. For my next example, I've said x is greater than -2 but we cannot include -2, so I can have -1, I can have 0, I could have 1, 2, 3, 4. Can I have 5, Violet? Can I have 5? Yes, I can include 5 this time because I've got less than or equal to. So equal to 5 is a possibility. And for the last one, I was looking for 5, which is included. 4, 3, 2, 1, 0, -1. Can I have -2, Amelia? No, I can't because I haven't got that equal to sign in there. Please make sure you've got these examples written in your dark blue books for me, Year 8. Okay, let's have a go at some practice questions. For example, the first one, I've said x is less than 8. X is 7. Is that possible? Yes, it is. 7 is less than 8. So yes, that's possible. I'm also going to go through this one. I've got x is greater than 3 but less than 8. I've got the number 3.0435. That's not 3, that's greater than 3. So yes, that's also possible. Can you pause the video for 10 to 15 minutes, Year 8, and in your light blue books, complete these questions now, please. And these are the answers. Please check your work and see how you did. Okay, I've got another set of questions for you to complete. At the beginning, I would like you to list the integer solutions to the following inequalities. Some of them have already been done for you to help you out. Please pause the video and have a go at these in your light blue books. If you're confident, have a go at my extension questions. Pause the video and have a go at that now, please. And these are the answers. Please check your work and see how you did. If you tried my extension questions, these are the answers I was looking for. Please check how you did. Well done if you got those right. Okay, we're going to go back to looking at inequalities on a number line. So again, can you write the title in your dark blue book, Inequalities on a Number Line, and a subheading, we're looking for double inequalities. So in your dark blue books, inequalities on a number line, double inequalities. We don't need to write this out again. We've already got that written in our dark blue books. That's just there as a reminder. So just as before, I'm going to go through an example and then you're going to do a similar example. So pens down, eyes on me to begin with. I need to show the inequality x is greater than or equal to -2 and less than 2. Let's start on the left hand side. I want greater than or equal to -2. Because it could be equal to, I'm going to fill in my dot. Let's have a look at the other side. X is less than 2 but not equal to 2. So this time the 2 is going to have an empty dot. And we want to show all the numbers in between those dots. So we join them up with a line. I'll do another example. This time I've got that 5 is greater than x. Again, we're not including the number 5, so it's an empty circle. But x is also greater than or equal to 0. Because it's equal to, we're going for a filled dot. And then we're going to join those up. Let's double check. If I had the number 1, that would be greater than or equal to 0, and it would be less than 5. So yes, this works. Over to you, Year 8, in your dark blue books. Have a go at these two examples. Pause the video for a couple of minutes and complete that now. Right, let's go through some answers. So we've got x is greater than or equal to -2. Because it could be equal to, we're going for a filled in dot. We've also got that x is greater than -4. Where's -4? There it is. It can't be equal to -4. So it's an empty dot. We're going to join those up. The number that's included in this inequality is -3. Is -3 going to be less than or equal to -2? Yes, it is. Is it greater than -4? Yes, so it works. One more example. I've got -5 and x is greater than -5. So I need an empty circle on -5. But x is less than or equal to 0, so it's got a filled circle on 0. Let's join those up with a straight line. And that's your example. Please make sure you've got this written in your dark blue books for me. And when we've done that, switch to your light blue books and have a go at these questions. For part A, I would like you to match the number line to the inequality. So each of those number lines matches to an inequality. Can you spot which one it is? And for part B, we've got some more number lines. Can you match those to the inequalities? Pause the video and have a go at these questions in your light blue books now, please. Feel free to number the number lines, so this could be question 1, 2, 3, 4, just so that you can keep track of which question you're doing each time. And for the bottom question, you're matching up letters. So pause the video for 10 minutes and have a go at those questions for me. And these are the answers. Please check your work and see how you did. This was question 1, 2, 3, 4. Five, 6, 7, and 8. And then for part B, the answers I was looking for were A goes with B, D goes with E, and C goes with I. Okay, Year 8, this was our lesson destination of today. Please pause the video and have a go at these questions in your light blue books now, please. This should take about 5 minutes, maybe a little bit more. Off you go. And these are the answers. Please check your work and see how you did. And finally, a little challenge for you. I've been asked, W and X are whole numbers. I know that W is greater than 40. So I know that W could be 41, it can't be 40, 42, 43, 44, etc, etc. I've been told that X is less than 30, so it could be 29, it could be 28, it could be 27. And I've been asked to find the smallest possible value of W, take away X. Now to do this, I want W to be as small as it can possibly be, which would be 41, but I want X to be as big as it can possibly be, which would be 29. So the smallest possible value of W take away X is going to be 12. Over to you, Year 8. Pause the video for a couple of minutes. Have a go at the second question for me. List those integers first. It's going to help you out. Right, let's go through the answers. We've got Y is less than 60, so we could have 59, 58, 57. Z is less than or equal to 50, so it could be 50, 49, 48, etc, etc. This time I want the largest possible value of Y plus Z, so I want both those numbers to be as big as possible. The biggest Y was 59, the biggest Z was 50, so I was looking for 109. Well done if you got that right. That was a GCSE question that I pulled out of a recent paper. And that's the end of today's lesson. Please head over to Google Classroom and complete today's exit ticket. Thanks very much for listening and have a lovely day.